In this video, we are going to derive the mean and standard deviation of a negative binomial. So we know that the probability mass function of a negative binomial is given by x plus r minus 1, r minus 1. And this is the probability of success. This is the probability of failure. So our mean is going to be equals to summation of all value of x from 0 to infinity times the probability mass function. So we are going to enter this into this. Our mean is going to be equals to all values of x from 0 to infinity x times, this one can be rewritten as x plus r minus 1 factorial out of r minus 1 factorial times x plus r minus 1 minus r minus 1 factorial times the probability of success times probability of failure. So this r and this will cancel. So we are going to remain with x factorial, r minus 1 factorial in the denominator. But then we know that x factorial is written as x into x minus 1 factorial, and then 1 out of r minus 1 factorial is written as r into r minus 1 factorial. It's the same as r out of r factorial. So we're going to feed this into the equation. Summation of all values of x. But then we know that x can't be 0, because when we feed 0 here, the whole of this is going to be 0. So we're going to change x to start from 1 to infinity. X times x plus r minus 1 factorial out of this is going to be r out of r factorial times x into x minus 1 factorial minus b. Then this x and this x will cancel, and then we're going to take this r up. So going to be summation of all values of x from 1 to infinity r times x plus r minus 1 factorial out of r factorial times x minus 1 factorial times 1 minus p. So this p can be written as p times p x minus 1, and then also 1 minus p. Or can be written as 1 minus p negative 1 minus p r plus 1. So we're going to fit this into the equation. Summation of all values of x from 1 to infinity r times x plus r minus 1 r factorial x minus 1 factorial, and then it's going to be p times p x minus 1 1 minus p power negative 1 minus p power r plus 1. So we're going to remove the constants out. R p out of 1 minus p times summation of all values of x from 1 to infinity x plus r minus 1 factorial out of r factorial times x minus 1 factorial. So we are going to be left with this and that. This is the same format with the PMF, just that the power here is x minus 1, but then we have x and here is r plus 1. So we are going to let x minus 1 equal to y, and then r plus 1 equals to 2. So here our x is going to be equals to y plus 1, and then our q is also going to be equals to, our r is going to be equals to q minus 1. So x plus r minus 1 is going to be equals to y plus 1 plus q minus 1 minus 1. This and this will cancel. We're going to remain with y plus q minus 1. So we are going to enter all this into the equation. But then when we are changing the equation, so we're going to change the value of x to y also. But then y is going to start from 0 to infinity. then here is going to be y plus q minus 1 factorial out of the error value was q minus 1 factorial, x minus 1 was y factorial. This is going to be y times 1 minus b power 2. But then now we know that this is the same as that. This is equals to 1. So 1 times this is going to remain the same. So our mean E of x is going to be given by Rp out of 1 minus p. This is our mean. So we are going to get that. So we are going to derive the standard deviation, and we know that the standard deviation is the square root of variance, but our variance of x is given by x E of x squared minus E of x all squared. So here we already have this. Now we are going to get E of x squared. E of x squared is going to be given by probability of all values, summation of all values of x from 0 to infinity, x squared times the probability mass function. So we're going to end. So we know that our x can't be 0, because when we enter 0, the whole equation is going to be 0. So we're going to make x equals to 1 to infinity. X squared times x plus r minus 1 factorial out of r minus 1 factorial times x plus r minus 1 minus r minus 1 factorial. So this and this will cancel, and we're going to be left with x factorial. As before we saw, our x factorial is going to be x into x minus 1 factorial, and then 1 out of r minus 1 factorial is going to be r out of r factorial. So we're going to fit this into this. So we're going to get the summation of all values of x from 1 to infinity, x times x plus r minus 1 factorial out of, this is r out of r factorial, and that is going to be times x into x minus 1 factorial. This x and this x cancels. So we are going to take this r up. So summation of all values of x from 1 to infinity is going to be r times x into x plus r minus 1 factorial out of r factorial times x minus 1 factorial, x times 1 minus p power r. So at first we also derived that this can be written as this, and then this can be written as this. So we are going to fit this into the whole equation. Continue and enter those values into the equation. So we're going to get summation of all values of x from 1 to infinity times x. Then our what? Our x plus r is going to be equals to y plus q minus 1 factorial out of our r was q, then our x minus 1 was our r was q minus 1 factorial, and then our x minus 1 was y. This is going to be qp power y p1, and this is going to be 1 minus p power q 1 minus p power negative. So we are going to extract out the what? The constants. So it's going to be rp out of 1 minus p times summation of all values of x from 1 to infinity. It's going to be y plus q minus 1 factorial out of q minus 1 factorial y factorial. Then here we're going to be left with p y, and then here we're going to be left with 1 minus p q. So we're going to expand this bracket and multiply it with the whole of this constant. So it's going to be rp out of 1 minus p. Then the whole of this, we're going to do, our x here was given by y plus 1, so it's going to be y summation of all values of x from 1 to infinity. So y into y plus q minus 1 factorial out of q minus 1 factorial y factorial, probability of success times probability of failure. And then plus 1 times summation of all values of x from 1 to infinity times y plus q minus 1 factorial out of q minus 1 factorial y factorial, probability of success times probability of failure. This is y. There is also y. So we know that the whole of this equals to 1, and then the whole of this is the same as the mean of y. So here is going to be rp out of 1 minus p times plus 1 times 1. But then remember, our y, we got it when we let y equals to x minus 1 from the first when we're deriving the mean. So our mean of y is the same as qp out of 1 minus p. But then we know our q was r plus 1. So we're going to feed this q into this, and then we're going to get rp out of 1 minus p into p into r plus 1 out of 1 minus p plus 1. When we open these brackets, we're going to get rp into 1 minus p. So when we multiply this, we're going to get rp plus p out of 1 minus p plus 1. So when we let the LCM here, it's going to be 1 minus p. So we're going to do the whole of this. So it's going to be rp out of 1 minus p times, this is going to be rp plus p plus 1 minus p out of 1 minus p. This p and this p will cancel. When you multiply this, you're going to get r squared p squared plus rp out of 1 minus p squared. But then you know this is not the value of the variance, so we're going to, this is a of x squared. Our variance was given by e of x squared minus the mean all squared. So we're going to substitute that, whatever we got, plus rp out of 1 minus p squared minus the mean was rp out of 1 minus p all squared. So we're going to get rp p squared plus rp minus r squared p squared out of common LCM is going to be 1 minus p squared. So this and this will cancel, and then our variance is going to be rp out of 1 minus p squared. But then recall that we said our standard deviation is the square root of the variance. So our standard deviation is going to be equals to rp out of 1 minus p squared all under root, and that's our standard deviation.